Okay, so for our example that we have here, tells us we want to use the definition above, so use the limit definition. To show part A, limit as x approaches 7 of 5 is 5, and then part B, limit as x approaches 7, just kidding, limit as x approaches 4 of 3x plus 1 is 13. Okay, so I need to show for part A, I need to show that the absolute value of f of x minus 5 is arbitrarily small, so we'll say just as small when x value gets very close to 7. Okay, so we want to show distance between f of x and 5 is small when x gets close to 7. Well, since we're looking at the number 5, f of x is 5 in this situation. So as f of x is 5, we get 5 minus 5 equals 0 for this whole thing. So this one we get for free. The absolute value is 0 always, including when x is close to 5, it's close to 7. So we're done. We showed that the absolute value of f of x minus 5, that equals, in this particular case f of x is 5, that equals 5 minus 5 equals 0 as x approaches 7. So that shows that the function values as x gets close to 7, the distance between the function values and 5, they're 0, and 0 is as close as it gets. So we're good there. So that one is kind of a cheap one because it's sort of a setup to automatically work, and we didn't really get to see much interesting there. This one over here, part B, will be a little bit more interesting, where I think you guys will be able to get a better feel for what's going on here. So for this one, we need to show the absolute value of f of x minus 13 is small as x gets close to 4, but not equal to 4. So we just say once x gets really close to 4, we want to show that the distance between f of x and 13, we want to show that that distance is getting very small too. So let's see what we got. So we'll start out with f of x minus 13. F of x in this case is 3x plus 1, so that's minus 13. That equals absolute value of 3x plus 1 minus 13 is minus 12. So I'm able to factor a 3 out. And then absolute value of 3 is 3, so we get 3 times absolute value of x minus 4. So what we'll note here is, as x gets close to 4, this right here is the distance between x and 4. No one can read that, so let's just write it a little bit bigger. This right here is the distance between x and 4. So as x gets close to 4, this distance here will be close to the distance between as x gets close to 4, the distance between x and 4 approaches 0. So this distance here will approach 0. If you have something that's approaching 0, 3 times something approaching 0 still approaches 0. So basically, we can wrap this up as f of x minus 13. That distance is equal to, stop drawing, stupid pen thing. That distance is equal to, oh my gosh. Okay, there we go. So that distance is equal to 3 times the absolute value of x minus 4. And as this is a, so this right here, f of x minus 13 is a multiple of the distance x is away from 4. So because this is true, then as x approaches 4, so as x approaches 4, then the distance between x minus 4 approaches 0. So that will approach 3 times the distance between x minus 4 will also approach 0. Because something approaching 0 times 3 still approaches 0. So we get the distance between f of x minus 13 approaches 0. So basically this whole thing here, this is true because the distance between f of x minus 13, that is a multiple of x minus 4. And since 4 is the number that you're looking to be close to, that had everything work out nicely in this case. So we'll stop there.